Well, okay, there we go. Another video, another day. Exercise application assignment, episode 23. Avery cameo. Alright. Let's see. That's what we've been working on. What did we do today? We did rear delt flies on the machine. We got the machine I wanted this time around. Dumbbell lateral raises, cable curls, rope hammer curls, cable forearm flexions, cable forearm extensions. I wrote down the pronations this time because I did 2 sets of everything. Incline chest press machine, did some dips and some cable crunches. How does this tie in? Let's look at it. Let's talk about the second messenger system this time around, because I believe I was talking about the slow acting hormones. I did get to talk about the second messenger system in detail. Let's look at it. So there's 2 second messenger systems. We have the G protein and the phosphorylase C. We have the CAMP and the phosphorylase C system. So we have the hormone binding to the extracellular receptor site. And the G protein is activated. G protein activates adenylate cyclase. Adenylate cyclase converts ATP into cyclic AMP. And then protein kinase A is activated, and then you have your cellular response proteins. So what operates that way, when we have exercise? What is our fat? This is kind of like our fast-acting hormones. What operates that way? Well, I believe I maybe talked about it before, but just to review, we have the hormones that spare our blood glucose during exercise, which is essential because if our blood glucose gets too low, brain dies, coma death, So we have epinephrine, norepinephrine, and then insulin and glucagon during exercise. So epinephrine and norepinephrine are going to stimulate the alpha and beta cells and the alpha beta receptors of those cells in the pancreas during exercise. So we need, during exercise we're going to go through glycogenolysis and lipolysis, and we're going to increase gluconeogenesis, and our plasma glucose is it's not going to go up, but the idea is really to get our plasma glucose up because we're using so much sugar when we're exercising. During rest, the exact opposite happens. We have the storage of fats, glycogen, and proteins, so we have glycogen synthesis when insulin is active. But insulin is going to increase, it's going to act through another system, right? There's another system with which hormones can act. Membrane transport, right? So insulin receptors activate glycogen synthase, which adds glucose to glycogen molecule, and our GLUT4 transporter is activated, and GLUT4 is basically going to travel to the membrane, pull glucose in from the the blood and the interstitial fluid and whatnot. So that's what's going to happen there. That's important. We're synthesizing glycogen. Why would we care about an exercise synthesizing glycogen? Because when we go to exercise next time, we want to have our glycogen stores up. Our glycogen stores aren't up, we're going to fatigue very quickly. Because like I said, your body wants to break down glycogen. And it would prefer to use glycogen first. Why? Because fats burn kind of in the flame of carbohydrates. Carbohydrates get glycolysis going. And what does glycolysis give us? It gives us pyruvate. Pyruvate can then be converted into acetyl-CoA by chopping off one carbon, getting CO2. And that's what's going to allow us to undergo the Krebs cycle to produce energy during long-term events. But what's that? Dust. So that's why we need that. Let's see. What other stuff is going on? Thyroid hormones are going to regulate your metabolism, but we want to have our glycogen up. So this is what was my main point. We want to have our glycogen up so that when we go back into exercise, we have enough energy to exercise, so we can create an anabolic stimulus. We can create an adaptive stimulus that's worthwhile. If we don't have our glycogen stores up, we're not going to be able to do as much work. Especially in a hypertrophy context. You have your phosphocreatine system, right? So we have PCR. What is it? We have PCR plus ADP gives us ATP, right? we have that obviously for super quick bouts. But when we're doing hypertrophy work, it's kind of in that mid range. We want glycolysis to happen, so we got to have glycogenolysis to happen. But glycogen can enter into glycolysis directly, which is another reason why it's important. You got to have that energy. If you're an endurance athlete, you can be on a little keto diet and it doesn't matter. But if you're training for hypertrophy, you want to get jacked and stacked and tan, then you got to have that glycogen storage.